I'm Dr. Mohammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today I want to discuss about I/O multiplexing and I/O models in network programming. I/O multiplexing and I/O are the models here in which we can use the TCP echo client. TCP echo client, that means transmission control of the protocol. This echo means here same message can be transferred. Whatever the message, echo client means whatever the message is sent to the server, same message are received by the client. That is the meaning of the echo client. So this TCP echo client is handling two inputs at the same time. So that is a standard input and TCP sockets. When the client was blocked in calling a read or write the operations, the server process was killed. Here, this is the multiplexing, input output are the multiplexing. That means multiplexing means here the multiple the inputs and producing the single output. That is a multiplexing. This is the multiplexing can be utilized in a client server communication. So that should be the echo client and echo server. Here I/O multiplexing server, TCP sends FIN to the client at the TCP, the final to the client at the signal. FIN signal can be sent to the client TCP, but the client never sees FIN signal since the client is blocked, reading from the standard the inputs. So we need the capability to tell the kernel, that is a kernel operating the system, that we want to be notified if one or more input output the conditions are ready for performing the process. I/O multiplexing, input output of the multiplexing, now which is selecting the operations. Now we can perform in the multiplexing, selecting the set of the inputs and polling or never select the functions. Here the scenarios for the input output the multiplexing, many inputs and a single output can be produced. Here the client is handling multiple descriptors, that means interactive input and a network socket. Client to handle the multiple other sockets, that is rare. And a TCP server which handles the both a listening socket and it's connected to the socket. So these are the scenarios. Server handles both TCP and UDP protocol, transmission control protocol and user datagram protocol. Both can be handled by the server in I/O multiplexing. Server handles multiple other services and multiple protocols. Here I/O models in a I/O in input output multiplexing and the I/O models. The I/O models are generally in multiplexing. Now can design the 5 types of the input output models which are available. We are utilizing in the Unix operating system. The first model is blocking the input output. Second model, non-blocking input output. Third model is a input output multiplexing, so which performing the selecting the set of input output and the polling to the processing. Signal driven input output, that is a SIG/IO. Asynchronous input output, that is a portable operating system interface, AIO underscore other functions. These are all the 5 models can be utilized in input output model under Unix operating system. It can be processed by using these five models. Now, multiple other inputs can be sent to the process, and a single the output can be generated in these processing, multiplexing processing. For that, now we can utilize these other models. Here, two distinct other phases for any other input other operation. The first other phase now we can use waiting for the data to be ready for other process. That means here at where we are waiting at the socket at the client side and receiver and the server. That means the receiver side means the server side, client at the server side the sockets. Now you are waiting for the data to be ready, and client is ready to sending the data. Once the client is ready to sending the data to the server will be the server socket will be the ready to receiving the data. It is waiting for the data to arrive. Server is waiting for the data to arrive on the network. Then copy into a buffer within the kernel. Here, whatever the data received by the server, it will be copied into the buffer within the kernel operating system. Copying the data from the kernel to the particular other process, related other process, from kernel operating other system to kernel, that is a kernel operating system, while utilizing the buffer in a kernel operating system. Now you can set as a kernel buffer into the application buffer. Whatever the applications you are running, client to the server, whatever the applications are running on a server side, generally the client sending the number of the applications. Now we see the client side. So it is the client utilizing the number of other application. Here the one of the applications now which is requesting the other service, which is requesting the which has the number of applications. Application 1, 2, 3, number of application. One of the application can be requested to the server other mission. Here, like this, now we can establish copying the data from the kernel to the processing. Once if it is this application, that means here from kernel buffer into the application buffer. So here all these application, whatever the applications you are using, all these applications can be stored in a application buffer. In this application buffer, all the applications can be stored. One of the applications, whatever the applications we have stored, that can be copy of this application data can be sent to the server machine, and we can run the process. We can run the data and processing the data in a server other mission. So this is about the kernel buffer applications to into the application other buffer. So in these the two other distinct phases of the input operations can be performed in a IO in this IO multiplexing and IO modeling, input output modeling. Generally two categories. Input output modeling, now we can utilize the two categories. One is a synchronous input output. So synchronous input output now, which is causes the requesting process to be blocked until that input output of the operations. That means receiving from the, and whenever the input output operations are completes, that means blocking, non-blocking, IO multiplexing, signal driven input or the output. So which is causes the requesting process to blocking until the input operation is complete, and asynchronous input or the output. Here is asynchronous input output which doesn't cause the requesting process to block. Here is synchronous input output now which is causes for the blocking, and asynchronous input output so which is not cause for requesting process to blocking. So these are all the two categories can be utilized. And first the model in the IO model, input output model, blocking input output model. The most the prevalent model for input output is the blocking input output model. By default, all sockets are blocking. In this is the figure now. If you show, this is a blocking input output model. Here is the processor blocks in a call to receiving other from. That is a application and receiving system calls. Now, which is from the kernel, the Unix or the operating system. Now, which is receiving the signals. Once now this system is calling, no data is ready, no datagram is ready at a kernel application, at kernel side. This is a application side. So kernel, this is a server side, it is the client side. So here is by this the system, whenever the system is called, no datagram is ready, and datagram is copying the datagrams from the kernel operating system, waiting for up to that here the copying the data from the operating system, kernel operating system. Now waiting, the server machine is waiting for the data. Once once the datagram is ready for the processing, if it is copied, the data is copied from the kernel data, it is process is copying datagram is completed. Now we can say it as a copy completed. Copy the data from the kernel to the user. That is, a user is nothing but we are copying the kernel to the client. User is acting as a client, and copy is completed. Once the copy is completed, which returns okay, the process the datagram. The datagram can be processed. The effective here is it is the processing. Now the task can be completed. This is a process blocks in a call to receiving from client, whatever the signals are from the system via the system calls receiving. This the process should be blocks in a call to the receiving from. These are all the applications. Number of the applications can be maintained at the server, at the client side. One of the application, the requesting. One of the application is requesting to the server for running. So this is about the blocking. So while it is requesting now, is a copying is the completed. Now it may be the block. So when it is the block, waiting at the time. The more a time is waited. So the server is waiting the more at the time. Now in this situation, it will be blocked. And UDP, user datagram protocol, is used in this example. Here is now, instead of the transmission control protocol, because now with the UDP, the concept of data being ready to read is very simple. Either an entire datagram has been received or it has not. With this transmission control of the protocol, it gets more complicated, as a additional variables such as the sockets low watermark come into the play. Now in this the figure, now if you see this the figure, so in this the figure, the process call receiving from the system calls, the process call. Now in this the process the call receiving from the system calls, receiving from the system the calls here. System calls does not returns until the datagram arrives and is copied into our the application buffer at a client side, or an error occurred. The most of the common errors in the system call being interrupted by the signals. The process is blocked the entire time from when it calls receive from until it returns. When receive from returns the successfully, the application process the datagram, whatever the applications now we are using at a client side, that can be processed to datagram. Datagram here, so in the form of the frames, the data can be sent in the form of the frames. Whatever the information, data can be sent from client to the server in the form of the frames. That is a process to the datagram. Here is a non-blocking input-output model. Non-blocking input-output model. Now, when a socket is to be non-blocking, when an IO operations requested that cannot be completed without putting the process to sleep. Do not put the process to sleep, but returns an error. Instead, this is the figure here, non-blocking IO model. Here is the applications and it is a kernel side, that is a kernel operating system. Now, if you see, for the first three receiving, there is no data to return, and kernel immediately returns the error of the E would block. That means here first three E would block. Here is the other block 1, 2, 3. These three here. Now in the first the first three receive from. There is no data to returns, and the kernel immediately returns an error. For the fourth time, we call receive from a datagram is ready. It is copied into our application buffer and receive from returns the successful. The data is further processed. Here in this the figure now, if we see first the three, it is a blocks 1, 2 system call. First three system call receives and no datagram is ready here, waiting for the data. Here is the kernel waiting for the data, and here also native data waiting for the datagram. If the datagram wait for certain time, it is waiting for certain time, it is wait for 20 minutes or 9 minutes or based on the time setting here. Now it is waiting. Once the data is available, the data is ready from through the system call. Now it is copied from the kernel. Copy the data from the kernel to the particular the user. That means the user means copy to the application. Whatever the applications you are using at a client side now, we are copying to the application and returns the OK. Process the datagram and process the datagram. Here the process repeatedly calls the receive from waiting for an OK returns. That is the polling. Here is the non-blocking IO models. So for the first three receive from, there is no data to returns and the kernel immediately returns an error. Could be the blocked. For the further time now, we can call receive from a datagram is ready. Whenever the datagram is ready, it is copied into our the application buffer and receives the return successfully. The data is further proceed. When application sits in a loop calling receive from on a non-blocking the descriptors like this, no, it is called the polling. Here is the application is continuously polling the kernel to see if some operations is ready at the kernel side. So this is often a waste of the CPU time, but this model is occasionally encountered normally on the system detected to one other function. Here is the IO multiplexing. With IO multiplexing, we call, select or poll and block in one of these two system calls instead of the blocking in the actual input output of the system of the call. Here in this the figure, we see applications selecting system call, more datagram is available. Now it is waiting for the datagram, returns the reliability. And here if the datagram is ready and which is receives from the system calls, copied the datagram is received from the system calls and copied from the kernel to the user. And copy is completed and returns to the user, and further the proceedings can be done for performing the options. That means here for performing the operations now, returns if it is returns OK, now can perform the operations. Process block. While the data are completed into the application the buffer. Now here what we are processing completed, the data can be stored. The data can be stored in a application buffer. In application buffer now we can storing the data. Here we blocks in a call to seller, waiting for the datagram of the socket to be readable. When select returns the socket is a readable, we then call the receiving from to copy the datagram into our the application buffer. Comparing to the blocking input output model, here the disadvantages and advantages are: disadvantage is using the selector requires two system calls, that is a selector and a receive the from instead of the one. Advantage is now we can wait for more than one file descriptors to be ready. Up to that, now we are waiting. That is a advantage of the this IO blocking comparing to the IO blocking model. This is the advantage. Multi In a multiplexing now, we can use the multi-threading with blocking input output. Here in this model, another closely related input output model is to using the multi-threading with the blocking the input output. Now, by using the multi-threading now, we can block the input output whatever the signals now we are receiving. That model is very closely resembles that the model which describes. So in this diagram, except that instead of using these the selector to block on a multiple file the descriptors, the program uses the multiple other threads, one per file descriptor. Generally, and each thread is an free is free to call blocking the system calls like receive from. Here signal as a driven input output. Signal driven input output model which is uses the signals, telling that the kernel to notify that these are signals with SIGIO, signal input output. Signals here when the file descriptor is ready. Here is this is a signal the driven output input output the model. The application establish the signal input output the signal handler and signal the action system calls which receives the signal system the calls and returns the these signal action the system the calls. So the signal handler can be handle these signals. Waiting for the data. Once datagram is ready, so deliver the signals. That means the signal handler. That is the through the which is datagram is ready, delivering the signals to the signal handler and receiving the signals from receiving the signals from the system calls and copying the data. If it is completed, copying this copying the data from application to the user. That is a client to the user. Here copy the data from the kernel to the user and returns the OK for further processing the data of the graph. Process blocks while data copied into the application buffer. Here this is about the signal driven input output model. We first enable the socket for the signal driven input output. Now install a signal handler using the signal action system calls that returns from the system calls is immediately to our processing for continuing the process. So it is not the block. The process is the continuing now. So it is not the block. When the datagram is ready to read the signal IO, that means that the signal is the generated for our the process. Now we can either reading the datagram from the signal handler by calling the receive from and then notify the main loop that the data is ready to be processed. Notify the main loop and let it ready the datagrams. Here is the advantage to this the model is that we are not blocked while waiting for the datagram to arrive. The main the loop can continue executing and just wait to be the notified by the signal handler that either the data is ready to process or the datagram is ready to be read. The asynchronous input output model in asynchronous input output model here now can be defined by the portable operating system interface specifications. Here it it is varies the differences in the real time the functions that appeared in the various of the standards which came together to form the current portable operating system interface. The specifications have been reconciled. This is the asynchronous I/O model. Here is in this the function works by telling the kernel to start the operations and to notify us when the entire operations, that means including the copy of the data from the kernel to our buffer, it is completed. The main difference between these models and the signal driven input output model is that with the signal driven input output, the kernel tells us when input output operation can be initiated. But with asynchronous input output, the kernel tells us when input output operation is completed. Here is in this the figure now can show asynchronous signal now reading through the system calls. The kernel here is no datagram is ready, waiting for the datagram and returns to returns. Here, if once the datagram is the ready available, copy the datagram from the kernel to the user. Copy is completed. Copy is completed. Deliver the signals. That is specified the asynchronous the signals, whatever the signals read, that can be delivered to the end user. That means that the through the signal handler, end user can be utilized. Signal handler process the datagram. Processing that can be continuously executing the process. Here, these are the while call the asynchronous read, the possess the asynchronous input output function, which begins with a asynchronous input output or library LIO and passes the kernel to the following file the descriptors, buffer pointers, buffer size. The signals can be processed to the descriptors for buffer pointers and buffer size. The same three are the arguments for reading and file offsets. That is similar to the L the C and how to notify as when the entire the operation is completed. The system call returns immediately and our process is not blocked while waiting for the input output to complete. Here is blocking, non-blocking. The differences are input output, the multiplexing, signal driven input output, the synchronous. Here is the initializing and initiating and completed. The process will be completed. Non-blocking also we are checking the data is available or not and blocked after blocked here. Blocked and the completing the process. IO multiplexing also checking for the data availability and blocked. If it is ready, the datagram is ready, initiating and completing the process here. And here is the notification can be initiated. If it is any blocks will be there, that can be blocked and process completing the process. Here also the initiate and the notification. Waiting for the data here and the copying the data from the kernel to the user and handles both the other phases. It will be handle the synchronous input output, handles both the other phases. And these one here the blocking, non-blocking, IO, multiplexing, signal driven input output. Now first phase handled the differently, second phase handle the same. So this is the comparison of the IO models. And here these are all the references for IO multiplexing and IO the models. The references for these are so these are the Unix network the programming and network the management principles and practices references. These are the textbooks references and these are the web references. So with this multiplexing IO the model, now effectively we can transmit the signals and process the signals. So continuously process the signals. So process signal processing purpose now for performing the task complete here signal processing task now. Generally we can use the IO multiplexing and IO models.
Like, share and subscribe. Hit the bell icon for more updates.